All right, this will be the first of 3 or 4 videos talking about examples of confidence intervals. So here we are. We've gathered some information about ACT scores from students at Carroll. This information came from a beginning of semester survey in Math 207. So I've got the Excel spreadsheet open up here, and what we want to do is we want to estimate the ACT score or the average ACT score for all Carroll students based on this sample. Now the sample is 73, item 74 here, but we got one title. So we got 73 ACT scores from Carroll students. Let's presume that they're randomly collected. So we'll do some basic statistics, descriptive statistics first. So let's do the average of A2 up to A74. And we're going to do the standard deviation of A2 up to A74. And the sample size. So I'm going to count. This is a little bit silly because I know that there's 73 of them, and that's okay. All right, now recall that the standard error when you're estimating means is the standard deviation over the square root of the sample size. And if I go too fast on any of these formulas, remember that you can put me on pause. So our standard error is rather small. And now, we're using the t-distribution here. So remember that with the t-distribution, it depends on the degrees of freedom. The degrees of freedom is the sample size minus 1. And if I have a large degrees of freedom, I'm close to a normal distribution. If I have a small number of degrees of freedom or a small sample size, I'm far away from a normal distribution. And remember that the difference here is in the area that you measure as you move away from the mean. So you can notice if I've got a very small sample size, the area between plus and minus 2 standard errors above the mean is actually rather different. If I have a large sample size, they're really, really close to each other. So in this particular case, the degrees of freedom, again, it's just sample size minus 1, so equals sample size minus 1, so degrees of freedom is 72. Now, building a confidence interval. My confidence interval is based on this particular collection of mathematical symbols. So mean minus my t-star, my critical t-value, times my standard error. Now, in a 90% confidence interval, this is t dot inverse of, well, let's see here. That's, if I just did 90%, I'm going to get a problem because remember, there's 10% left over, and all stats software reads from a z-score or a t-score down to negative infinity. So I got 10% left over. That's 5% in each tail. So let's pick up the left tail, comma, degrees of freedom. So there's my t-score. My margin of error is just this bit right here. So my t times my standard error. So that is my t-score times my standard error. So I'm going to go about 0.5 up from the mean and 0.5 down from the mean. And now I can build my confidence interval. So it's going to be mean minus margin of error, comma, mean plus margin of error. So lower bound is mean minus margin of error, and upper bound is mean plus margin of error. And there we are. Okay, so now the interpretation for that is if we gather many samples, sorry, let me get this so it's going to work here. So if we gather many samples of the same size in the same way, then 90% of the confidence intervals will capture the mean. So if we gather many samples of the same size in the same way, so 73 people gathered in the same way, 90% of the confidence intervals will capture the mean. Now, we don't actually know that this confidence interval between 24.3 and 25.4 actually gets the mean, but if we did this over and over, 90% of the confidence intervals we build will. So this one probably is pretty close. So let's do it for 95. So equals t dot inverse of, now let's see here. If I did 0.95, I'm going to have a problem because, again, the tails now contain 5% remaining. That's 2.5 on either side, so let's add that 2.5 in. My degrees of freedom is 72. My margin of error, again, is t-score times standard error. And notice this margin of error is larger than this margin of error. If I've got a 95% confidence interval, I need more wiggle room than a 90% confidence interval. So lower bound is mean minus margin of error. Upper bound is mean plus margin of error. Enter. And notice that I've got a slightly wider interval now. Okay, and for 99%, so this is t dot inverse of 0.995. Pause me and think about why that's true. Degrees of freedom. My margin of error is my t-score times standard error. Again, a little bit larger than these other two. And I'll build the lower bound. Oops. And the upper bound. Now the beauty is here is that confidence interval, the 90%, the 95%, and the 99% are all within rounding and telling me that, well, let's see here, between 24 and 26, that's going to be our average. So boy, you know, if I'm going to do 99 different samples and I'm going to find the correct interval, 99%, or I'm sorry, 100 different samples, and I'm going to find the correct interval about 99 times, I'm going to be pretty convinced that the average ACT is between 24 and 26. I hope this has been helpful, and look forward to another video on another one.